In this video, we are going to learn about hobby DC servo motors and its work. Before talking about a DC servo motor, let's first understand what is a simple DC motor. A DC motor is a device which converts the electrical energy into mechanical energy. A DC motor is not used for taking precise movements, as the only purpose of the DC motor is to produce continuous rotation. On the other hand, a servo motor is different. It provides a precise control on the movement of its drive shaft. Whenever you require a device that can take precise movements for your project, a servo motor might be the best choice. Internally, a servo motor is divided into two main sections: an electronic section and a mechanical gear section. Let's explore both sections one by one. Let's start with gear section. In a servo motor, the role of the gear section is to produce a low-speed, high-torque output. Torque of a servo motor is the amount of rotating force a servo motor can apply. The working of gear section is based upon the principle of gear ratio. Let's understand the gear ratio. Imagine two gears, an input gear having 12 teeths and an output gear having 36 teeths. Now we can put both gears together to form a simple gear arrangement. This simple arrangement has a gear ratio of 3:1. It means for every 3 complete rotations of input gear, the output gear take only 1 complete rotation. Due to this, the angular velocity of larger gear is become 1/3 of the smaller gear. Also, the torque for larger gear become 3 times compared to the smaller gear. And that's how a low-speed, high-torque output is achieved, using simple gear arrangement. Same concept is used in servo motor. A DC motor is used for driving the gear section of a DC servo motor. In gear section, the output gear in the motor is connected with a compound gear tray. For this specific servo motor, the equivalent gear ratio between the motor and output gear is 260:1. It means whenever motor rotates 260 times, the output gear rotates only 1 time. Because of this, the output gear has a very low speed as compared to motor, but a very large torque. The working of servo motor is based upon the feedback control system. As we already discussed, a DC servo motor uses a DC motor for driving its output gear. Servo motors uses potentiometer as a feedback sensor. Potentiometer sends signal to PCB about the current position of servo motor. A DC servo motor has a 3-pin connector. Generally, red wire is for power supply, a black or brown wire is given for ground, and an orange or white wire is given for PWM input signal. The rotation of servo motor is controlled by a PWM signal. We will discuss about PWM signals later in this video. Servo motors works in a closed loop system. When input is given to the control unit, it provides power to DC motor. As we already discussed, motor is connected to drive shaft using compound gearing arrangement. Drive shaft is also connected with the potentiometer. Here, potentiometer is used as a feedback sensor. Potentiometer provides information to the control unit about the current position of drive shaft. When drive shaft reaches the desired position, potentiometer sends signal to the control unit to stop the DC motor. Hence, a closed loop system is formed. The position of drive shaft is dependent upon the input PWM signal. Let's understand what is a PWM signal. A PWM signal is an analog signal. PWM signals are used in many applications, ranging from communication to power control and conversion. A PWM signal is a series of repeated rectangular pulses. Pulses repeat itself after a regular interval of time, known as time period of a PWM signal. Time period of a PWM signal is the sum of its on and off time. On time is the time during which signal is high. Signal is low during the off time. Most of DC servo motors uses a PWM signal of time period 20 milliseconds. Position of DC servo motor is controlled by varying the pulse width of input PWM signal. When input PWM signal has a pulse width of 1 millisecond, servo is at 0 degree position, 90 degree at 1.5 milliseconds, and 180 degree at 2 milliseconds. That means by varying the pulse width of input PWM signal from 1 millisecond to 2 milliseconds, we can move the drive shaft accurately at any position between 0 and 180 degree. Generally, a DC servo motor has a limited range of movement from 0 to 180 degree. Another type of servo motor is a continuous moving DC servo motor. Speed of a continuous moving DC servo motor is also controlled by varying the pulse width of input PWM signal. PWM signals for controlling servo motor can be generated using a number of methods, but most convenient way of generating PWM signals is by using a microcontroller. A microcontroller, like Arduino, can generate PWM signals of any desired pulse width and duty cycle. Hence, we can easily control a servo motor by using a microcontroller like Arduino.